these are the answers and how to do all of the questions for the Chapter 3 quiz. I want to remind you that when you take your quiz, when you turn it in, you have to put your work on it. If you just write the answers, you will not get credit for those questions. So please show your work. All right, so for number 1, the question says, is negative 4, 3 a solution to this system? So remember, an ordered pair is in the form of x comma y. So we just have to plug in the x and y values and see if it works in both equations. For it to be a solution, it has to work in both, not just one. So for the top one, we would have to do 2 times negative 4 plus 3, and we have to get negative 5 for an answer. So 2 times negative 4 would give us negative 8, and negative 8 plus 3 would give us negative 5. So that one works. Then we have to try out the bottom equation. So we would have negative 4 plus 2 times 3, and we should get an answer of 2. So this would simplify down to negative 4 plus 6, and negative 4 plus 6 is 2, so that one works as well. So yes, this is a solution. For number 2 and 3, we're going to solve the system using graphing, substitution, or elimination. You get to pick which version you liked the best and which one made most sense to you. I would not suggest graphing just for the simple fact that you have to solve both equations for y and then try to figure out where they cross on a graph. So I definitely suggest substitution if one of the variables is already solved. So if you have y equals like this one or x equals, then definitely use substitution. Elimination is where you want to use them where the x and the y's are lined up, like in number 3. So for number 2, I'm going to show you substitution. And again, if you want to rearrange them and use elimination or and do graphing, that's fine. I'm just trying to show you the easiest ways for the way they're set up. This one is y equals x plus 3. So wherever there's a y, we're going to put x plus 3. So I'm going to have 2x plus 4. And that y is going to be replaced with x plus 3. Notice I didn't keep the y, I replaced it, or I substituted it for x plus 3. Now we have to simplify, so we're going to do distribution here of the 4. 4 times x would give us 4x, and 4 times 3 is going to be 12. Then we're going to combine like terms, so 2x and 4x would make 6x plus 12. And then we're going to subtract 12 from both sides. So I'm going to have 6x equals 12. And then I'm going to divide by 6 on both sides. So I have x equals 2. So that is half of our answer. And I'm going to take that 2 and plug it into one of our original equations. And it looks like the top one would be the simplest. So I'm going to do y equals 2 plus 3. That x is now a 2. So y equals 5. I'm going to finish writing my ordered pair. So the solution of that system is 2, 5. Number 3 is the one I was talking about with elimination, how the x's and the y's are lined up. When you have those lined up, you want either the coefficients of the x's or the coefficients of the y's to be the same number. So in this case, we have 4 in front of the y, or negative 4 in front of the y's. We want one to be positive and one to be negative. So I am going to go through and make one line. I'm going to make every number opposite. So I'm timesing by negative 1, really. So that would be a negative 5. This would be a positive 4y. And 0 is just 0. It doesn't get to be negative. But if that was a different number, I would make it opposite. Now I can add going straight down. So a negative 5 and an 8 would be 3x. 4 and negative 4 cancel out. And 0 plus 12 is 12. So divide both sides by 3, and 12 divided by 3 would give us 4. So our x value is 4. Now I'm going to plug that back into one of the original equations. So I'm going to get rid of the changes that I made here, and I'm going to plug x in to the top one for the x. So 5 times 4 is 20. So we have that, and then I'm going to subtract 20 from both sides. So I'm going to have negative 4y equals negative 20. And then I'm going to divide both sides by negative 4. Negative 20 divided by negative 4 would be a positive 5. So our ordered pair where these two lines cross is 4, 5. Number 4, we're going to graph this system of inequalities. So we're going to put, we have to solve both equations for y. That first one is not solved for y. So I'm going to have to minus x from both sides. So I'm going to end up with 0 minus x, which is really just negative x. Now I need that plus or minus at the end so that I can have a y-intercept. So it would be just that plus 0. So a dot at 0 for the y-intercept. Our slope is negative, so I'm going to go down 1 and over 1. And I'm going to do that in both directions to continue the line so we can see where it's at. The inequality symbol is not underlined, so I'm going to make this a dotted line. And then y is less than, so we're going to shade under this line. Then I'm going to graph the other one. The only thing that I see wrong with this one is that, oops, it should be negative x plus 4 if it was in the mx plus b form. So my y-intercept is positive 4, and the slope is negative 1. So that means I'm going to go down 1 and over 1 as well. So extend a few in both directions. This one is underlined, so we're going to have a solid line here. And then y is less than, so we're going to shade under this line. And then our answer is where do they overlap? So in a different color, I'm going to make it darker. They overlap underneath of that dotted line. So any solution there, any ordered pair that's in that blue, black, and red area would be a solution to this inequality. All right, and then for the last one, we have to graph. And I am going to erase some of these lines since they're on our graph here. All right, we have to graph these 4 lines, and then we have to maximize the objective function p equals 4x plus 5y. So x is greater than or equal to negative 2. So we're going to put a line through negative 2. And x is greater than, so we're going to shade to the right. So anything over here is shaded. For the second one, we have y is less than or equal to 1. So that's going to be a straight across line through the y-axis at 1. And y is less than, so that's going to be under that line. And then we have y is greater than or equal to 1/2 x minus 2. So y-intercept is negative 2, and the slope is 1/2. So we want to go up 1 and over 2. And I suggest doing this all the way to the end of each side because then you can get your exact points at where your lines cross. So to go backwards, we would have to go down 1 and back 2. And it's a solid line. And y is greater, so we are going to shade above this. And our last one is y is less than or equal to negative 2x plus 3, so a y-intercept at 3. And negative 2 is our slope, so down 2 over 1, down 2 over 1, down 2 over 1. Same thing, up 2 and back 1 for the going backwards here. And y is less than this, so we're going to shade underneath of that. So now we're looking for the region where we have all of the colors. And we have to be underneath of the blue line, we have to be to the right of the black line, we have to be underneath of the red line, and we have to be above the pink line. So it looks like this little shape right in here fits all of those categories. So now you have to find the ordered pairs to where these lines cross. So I'm going to get rid of all of that shading there so we can see these points. So this point is 1, 1. This point is 2, -1. And so that takes care of that one. This one, as you can see, my red line didn't quite hit all the points it should have. This point here would be -2, -3. And then this point here is -2, 1. So now we take those 4 points and we plug each one into this equation of 4x plus 5y. And since we're maximizing, we're looking for the largest answer. So I'm going to start with that -2, 1. So I'm going to do 4 times -2 plus 5 times 1. So that would be -8 plus 5, and -8 plus 5 would give me -3. And then I'm going to plug in 1 and 1. So I have 4 times 1 is 4 plus 5 times 1 is 5, so that would equal 9. Then we have 2 and -1. Oops. So that would be 8 and -5. 8 plus -5 would be a 3. And then we have -2 and -3. So that would be -8 and -15. -8 and -15 make -23. So if we're trying to maximize, we're looking for our largest answer, which would be 9 here. And that was from the ordered pair 1, 1. So 1, 1 equals 9.